Okay, Wildcats. Today we're looking at Tuesday, January 30th, cube and cube root transformations on page 50. So if you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. All right, so first off, let's look at cubic transformations. Now this should look familiar. The transformations affect all functions the same way. So as where we've had parentheses in the past, we now have parentheses and to the third power, so cubic, okay? So when the negative is outside the parentheses in front of the a, it reflects over the x-axis. When a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When the negative inside of the parentheses in front of b, it reflects over the y-axis. And then when b is greater than 0 but less than 1, it's a horizontal stretch. And when b is greater than 1, it's a horizontal compression. When it's plus h, it translates left. When it's minus h, it translates right. When it's plus k, it translates up. And when it's minus k, it translates down. All right, so that's the cubic transformation notes. Now let's look at the cube root transformations, again on page 50. Now, same notes as we just saw, but instead of to the third power, we have the cube root, okay, in place of where the parentheses were, okay? So when negative is in front of the a, outside the cube root, it reflects over the x-axis. When a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When the negative is inside of the cube root, in front of the b value, it reflects over the y-axis. When b is greater than 0 but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. When it's plus h, it translates left. When it's minus h, it translates right. When it's plus k, it translates up. And when it's minus k, it translates down. All right, so go ahead and finish up your notes. All right, now your notes are finished. Let's take a look at the examples. Now, before we go over the examples, we need to go over the cube root parent function and the cubic parent function and the cube root parent function. Now, what I did this on a separate note card. You can do this on a piece of paper or whatever you like to do, but I recommend attaching this to your example so you remember. But so when we have x cubed, when x is -2 cubed is -8. When -1, x is -1, -1 cubed is -1. H and k are vertex, so 0 cubed is 0. And remember, this is what's going to move when you do your transformation. Well, that's what we move first, I say. All the points move, but this is what you move first. All right, and then when x is 1, it's 1 cubed is 1. When x is 2, it's 2 cubed is 8. Okay. Now remember, these are going to be your directions for your transformation. So you move the vertex first, and then you can apply these from the vertex. All right. Now let's look at the cube root parent function. So that's the cube root of x. So when x is -8, the cube root of -8 is -2. When x is -1, the cube root of -1 is -1. H and k, remember, that's your vertex. When h is 0, cube root of 0 is 0. When x is 1, cube root of 1 is 1. When x is 8, cube root of 8 is 2. And again, these will be your directions for the cube root functions. All right, now I'm going to attach these last, but keep those off to the side so you can use them on the examples. All right, example 1. First off, we name the function, okay? So we see that it's a cubic function. And this is space. I'm okay if you just write cubic, okay? Now, we really don't have space. Or we need the space, I should say, for the direction. So I'm actually going to mark out the name here, and I'm going to use that space for graphing by direction. But before I do that, I'm going to move the vertex. So that means the -1 means we move to the right one, and the -1 is down 1. So that's our new HK. Okay? And then we're going to graph by direction. And we know from the notes here that since it's cube root, we go, or yeah, cube root, so -2, -8, -1, -1, HK, 1, 1, and 2, 8. Okay? So we go left 2, down 1, 2, 3, 4, 5, 6, 7, 8. And we go left 1, down 1. And then we go to the right 1, up 1. And I didn't write it down, but we know that it's to the right 2, up 1, 2, 3, 4, 5, 6, 7, 8. All right, and we know from our notes from the past is that the cube root function, domain, and range are both from negative infinity to positive infinity. All right, so the transformations, we went to the right 1 unit and down 1 unit. Now at this point, if you understand how to do this, you could probably stop the video now and then finish the examples on your own. And you could also, if you're having trouble, you could basically wait and I can go over some of these in class and so on, okay? But at any point, if you're stuck, you can put a note and I'll go over those examples with you. And if at any point you understand, you don't need to continue the video, okay? You can just work through this on your own. But I will work through all the problems so you could always go back and check. All right, example 2. Okay, so we're first going to name the function, and it's a cubic. Okay, and again, just going to need to steal the space here so we can graph by direction. All right, so again, we know, well, before we do that, move the vertex. So that's +1, so we go left 1 and then up 2. There's your new vertex. Again, we graph by direction, so -2, -8, -1, -1, HK, 1, 1, 2, 8. So we go left 2, down 1, 2, 3, 4, 5, 6, 7, 8. Left 1, down 1. Right 1, up 1. Right 2, up 1, 2, 3, 4, 5, 6, 7, 8. Okay, and again, the domain and range for cubic functions is always -infinity to +infinity and -infinity to +infinity. Transformations. Oh, whoa. And I'm kind of glad I did this, but I actually made a mistake. Okay, pause for a moment and see what mistake, if you can catch, that I made. I'm hoping you saw that I overlooked the negative. That's why it's always good to go back and check your work. So that would actually affect the direction, so we need to multiply it by -1. And a simple graph and would check and verify that that was a mistake. Okay, so the vertex is still left 1 up 2, but now the direction it reflects over the x-axis. So this would be a positive 8, positive 1, negative 1, negative 8. So we go to left 2, up 8, 1, 2, 3, 4, 5, 6, 7, 8. Left 1, up 1, right 1, down 1, right 2, down 8. 1, 2, 3, 4, 5, 6, 7, 8. Domain and range is still negative infinity to positive infinity for both domain and range. So the transformations, and this is where I made the mistake. I forgot about the negative on the outside. It reflects x-axis. It's left 1, and up 2 units. All right. So now let's look at example 3. All right. So name cube root function. Okay, and again, we're going to graph by direction. All right. Now, first things first, we move the vertex. So the plus 3 means it go left 3, 1, 2, 3, and then down 1. Now we know the directions from our notes are negative 8, negative 2, negative 1, H, K, 1, 1, 8, 2. Okay, now I don't want to repeat the mistake I made from example 2, so I look in front, I see there's a 2, so that means I need to multiply all of the y values by 2. So the new directions are negative 4, negative 2, 2, and 4. All right, so from here, we go left 8. So 1, 2, 3, 4, 5, 6, 7, 8. Down 1, 2, 3, 4. Points just out. We can do that. And then down 1, or I say left 1, down 2. And then to the right 1, up 2. To the right 1, 2, 3, 4, 5, 6, 7, 8. Up 1, 2, 3, 4. All right, and we know that the cube root function's domain and range is both negative infinity to positive infinity. And the transformation is vertical stretch of 2, left 3 units, and down 1 unit. All right, now let's look at example 4. All right, so name, we know it's a cube root. And we're going to graph by direction. So we move the vertex first. So that -1 means you go right 1 and then up 2. And then we know for cube root directions, it's -8, -2, -1, -1, HK, 1, 1, 8, 2. But again, we have a -3 in the front, so we need to multiply the y values by -3. So that becomes +6, +3, -3, and -6. So from here we go left 8, 1, 2, 3, 4, 5, 6, 7, 8. Up 1, 2, 3, 4, 5, 6. Go left 1, up 1, 2, 3. To the right 1, down 1, 2, 3. To the right. Wait a second. That's not right. No, wait. No, that's right. 1. So then now to the right. 8. 1, 2, 3, 4, 5, 6, 7, 8. Down 1, 2, 3, 4, 5, 6. Okay, so we know our domain is -infinity to +infinity and -infinity to +infinity. Transformations. The negative, that means it reflects the x-axis. The 3 is a vertical stretch of 3. And then the -1 is right 1 unit. And +2 is up 2 units. All right, so now let's look at example 6. It says graph the cube and cube root inequality using transformations. Okay, so here we move the vertex down 1, and then we graph by direction. So we know since it's a cubic function, we know directions are -2, -8, -1, -1, HK, 1, 1, 2, 8. Since there's no line underneath, it's a dashed line. So we go to the left 2, down 1, 2, 3, 4, 5, 6, 7, 8. Left 1, down 1. To the right 1, up 1. To right 2, up 1, 2, 3, 4, 5, 6, 7, 8. No line underneath, it's a dashed line. And since it's greater than, we shade above. All right, let's look at example 7. All right, so again, we move the vertex to the right 3, so 1, 2, 3. Okay, and so then we go, again, we graph by direction. Now, since it's a cube root, we know the directions are -8, -2, -1, -1, HK, 1, 1, 2, 8. So from here we go left 8, 1, 2, 3, 4, 5, 6, 7, 8, down 2, left 1, down 1, right 1, up 1, and then that should be 8, 2. to the right 1, 2, 3, 4, 5, 6, 7, 8, up 2. Now, since there's a line underneath, it's a solid line, and since it's less than you shade below. All right, so there you go. There is cube and cube root transformations. At this point, you have two options. The first option, if you had some questions, you could wait till class and I can answer those questions. Option 2, if you understood the examples, you could go ahead and start working on the assignment. Either way, have a wonderful Wildcat day.